So in order to test the page algorithm, we're gonna enter the IBM SPSS environment, and we're gonna use a simulated data set with 6 feature predictors and 1 response variables or target, a binary target of values 1 and 0. In this case are ordered, and scale values for all the feature predictors. Various combinations are possible, but this, for the sake of the simplicity, the neural network as multi-layer perceptron to be built will be based on these 161 cases with 6 feature predictors and 1 response variables binary classifier. So I already preset that an original neural network as a multiple layer perceptron structure as a non-readable black box model, where we want to interpret the 6 feature predictors by to make a predictions on the binary target called YCAT, stands for category. So basically, there's the code for in SPSS code. This is we are rescaling the covariates, the 6 feature predictors into standardized. We're gonna use a training and a testing set with 70% training set and testing set 30% with no holdout. The architecture used for this multi-layer perception, it has a customized 1 hidden layer with an automatic numbering of hidden units that's generated by the internals of the SPSS algorithms, with a hidden function as an activation function that is sigmoid, as well as the output function will be a sigmoid. We're going to use a training mode batch training. So basically, we are going to update all the weights only after passing all training data records, basically. So the batch training is using all the information from all the records in the training data set. We're going to use as optimization method the gradient descent, and having a learning initial state as a default 0.4 by IBM SPSS with a alpha momentum of 0.9. We're going to print out various basics, descriptive statistics, case process summary, the network information, summary of the network reliability, classification tables, and especially the feature importance. So the predictor importance will be classified. That is the unique, IBM SPSS has its own way to compute the importance of the 6 covariates here, and is using basically an internal sensitivity analysis algorithm that will just generate the level of importance relative to the sample available over these 6 feature predictors. So then we're gonna plot even the area under the curve, the ROC receiver operating characteristics, as well as we're gonna save the predictive values class. So let's be clear, the original observed response class is 1 or 0, clearly, and will be a prediction of the class, and we will appreciate the level of performance of the prediction classification by the neural network. So staying on the code, we're gonna stop the training wherever a change in 1 step will just there's no change in the error rates. with an error change set to E minus 4, 1E minus 4, and an error ratio of 0.11001 for the ratio of the error included in the model. We're going to remove the missing values. So if we run the this neural network, let's see what we get in terms of performance and interpretability. We got the basics. This is the description of our syntax. This is actually the structure that has been run. We got the training and test set split on the cases. Clearly is a limited number of instances, but it's just as an exemplary case for the page model. We have the network information with the 6 covariates that has been standardized. We're gonna have a hidden layer, one single hidden layer with 4 units in the end. And the activation functions for the hidden layers as well as the outer layers is the sigmoid function. This is actually the resultant structure of the network. And we can appreciate here the percentage incorrect predictions overall is the around 10% error rates with sum of square errors of 7.084 and with a percentage of incorrect predictions around 10% basically. Looking at the classification case, we can see that we are in front of pretty much performing and reliable neural network. We can appreciate the overall accuracy on the training and the testing set is shifting from 90% to 89. Basically, there is around 1 point percentage differences in the cross generalization between the training and the test set. And we can see the focusing on the test set, the 89%, 90% is the level of the recall. The specificity is the same, 90%. We can appreciate that the performance both in the test set and in the training set is pretty high. This is well evident into the belly-shaped ROC curve with a 96.96 area under the curve value for the ROC curve, basically. And a very important chart is this one because actually this is a reflection of the internals and the sensitivity analysis algorithm of the neural network that is just stating that the feature predictors B and E with respect to the others are the key predictors impacting on the construction of the algorithm, and the importance of these 2 features are clearly well evident as independent variables into the system. So what we're saying is that B and E are the 2 main important predictors. But the question is that apart from this predictor importance, there is no specific readings on the leverage or the differentiation or the direction of the values in the features predictors, B and E. So basically, this is the only aspect that can be read by the internals of the neural network. So overall, what we have to do right now is just to be sure that we page the original neural network output as a description pattern of basically expected values across target variable classes, across the prediction classification and not the original classes in the target variable. And this is done by having the mode of the class clearly remains the class in itself, 1 or 0, but the predictors will get the aggregated averaging through the two classes. So in essence, here we go with the predicted classification with errors. This is a misclassification, for instance, but nevertheless, we need to find out a way to aggregate the ones into a single average value per specific feature predictors, and with particular attention with the B and the E according to the output of the neural network. To do so, we just ran a little piece of code still in SPSS syntax, declaring a new potential data set that we'll call page expectation, and we're going to aggregate each predictor feature by its own mean and breaking the means into the two groupings, 1 and 0, on the predictor class by the neural network. So if we put simply, we just run this piece of code, let's see what we get. Okay, the code is gone. Let's see, this page expectation is the new data file containing the previous original data set simply into a descriptive page version where we got the mean of each of the feature predictors, A, B, C, D, E, F, with a particular eye on the these values and on the E feature predictors. And these are corresponding not to the original target values, but the prediction values by the neural network. In this sense, it clearly is just only a description of a kind of a pattern description of aggregated values. The question here is that is it possible to describe if the difference between these two values are any significance at all, and the direction in terms of the prediction on the actual predicted values on the neural network. Is it there something that can be done? Well, actually, in the page system, we now are going to use another piece of code in still writing in the SPSS syntax to generate the first type of kernel that we said it is the application of a general linear model with multiple dependent variables, that is MANOVA, multivariate analysis of a one-way MANOVA, multivariate analysis of variance structure. Let's see on syntax what we mean with this. It is already preset here. So to reach the interpretation of the most relevant features, the B and E, we're going to interpret the original neural network output, especially the features of the neural networks, via the application of a statistical kernel that is the MANOVA, as we just said. So if we, this is the code for a general linear model with our previously feature predictors treated as in the MANOVA context as the dependent variables, multiple dependent variables, and with the factor that is actually the classification coming out from the actual prediction of the neural network. So now the neural network is acting as factor with two-level treatments, that is 1 and 0, over the dependent variables here that are acting into the MANOVA context and can be assessed by F-test values, as well as studying the overall feature rows and leverage into the MANOVA context. Let's see how it works. So let's run this into the SPSS. It's running. It's done. Let's go and see the system. So this is our first page kernel, the Manova system. This is our piece of code. We can just first check that the between subject factors is actually separating the classification in 0 and 1 classes. The multivariate test first shows that the linear combination of these features is significant. Wilkes lambda is just showing to prove quite significant with a high level of partial eta square. That's quite positive. It means that the variables altogether works quite reliably. Just skipping through the individual one-way F tests, we can first identify that's very important, that the two variables that really are accounting within this Manova context are exactly the B, see here, with a predictive, with a misclassification error rates for false positive, or the famous p-values below 0.001. And the other variable that is proved to be significant in line with the neural network is actually, again, the E. Two important predictors according to the neural network are revealing to be the two significant dependent variables into the Manova context. So first, this is a sign that we are on the same kind of recognition of the two original feature predictors in the neural network are reflecting their importance and significance, or error rates, false positive error rates, very low with respect to the other two. Now let's just go on. If we look at the parameter estimates, that's really make an advantage using this page algorithm to interpret the neural network. In fact, if we look at the B feature and the E feature, these are the only two significant in terms of this statistics as parameter, these beta values. Simply reading very simply this Manova output, we can see that on average, with respect to the classification class 1 in the predicted class by the neural network, with respect to the class 1, the class 0 is an average difference of minus 4.82 unit difference between the class 1. And this is significant. It's a low false positive classification error rates at stake. So that means that we can interpret that visually. We can see the B here. We can see here that actually the classification in class 0, these are the confidence interval, they do not overlap. So there is a significant difference between the two classes predicted by the neural network in the Manova context, shows that it is clearly there is a significant difference with the values in this B feature predictor lower for the class 0, and this is reflected by this picture. If we still go back to the parameter estimates, we can again check that this is the same. In the opposite direction, there is an average of 4.876 units on average higher when you've been classified in the 0 class with respect to the class 1 according to the feature predictor E. And it is really quite consistent and reliable results. And if we look at the other features, we can again mirror that these are not non-significant separation between the two classes. This is well above the standard classification, false positive classification or misclassification of minus 0.05, like the C still irrelevant, less reliable. The D, well, D is actually significance in this case that would deserve major attentions, and that's quite a difference. Again, the E, as we said, is significance, and the F is not significance. Overall, we are reflecting the results of the neural network within the MANOVA, plus the capacity to interpret the differences through the mean values between one class to another one and the direction of the average values. Just to be clear, when with this block, these line charts, we can see that when the confidence intervals of the mean per class predicted by the neural network are overlapping, there's no significant differences between the averages, the paged values on the features. This B is significant, as we said. C, no, they are overlapping. E is not overlapping, and F is not overlapping. So this is the MANOVA application to interpret and to give a meaning on the role and direction of the average differences between the original features B and E that has been shown important for the neural network, and by MANOVA application we can interpret their role into an interpretability within the neural network. In the next section we will see that the very same application can be obtained by a second type of solution, that is via a generalized logistic regression, as an example of a generalized linear model system.
So switching to the second statistical kernel option, the generalized linear model, instantiating the regularized logistic regression, will try to identify the very same results that we got from the MANOVA applications as before in the previous section. So in this case, we're gonna switch into the IBM modeler software, IBM modeler 18.1 version, and that's quite way far rapid to prototyping and testing models, machine learning models like this. So let's just recap that we have our source of data where we can just see a preview of the first 10 rows, and we can just check out that actually we have the previous 6 predictor features, and the actual original target variable and the prediction target from the neural network, the multi-layer perceptron, according to the previous section of the video. And that's now is we're gonna use a regularized logistic regression on this observed target that is actually the prediction of the previous neural network model. And we're gonna apply a logistic regression regularized model. Regularized logistic regression by ridge regression, L2 lambda method, simply because the overfitting of the very same initial predictive features over already predicted values will certainly overfit the results of a normal logistic regression or a generalized with link function model, as we certainly will see in the end of this section. So we have the data set we set up that are continuous variables, our predictor features within the workbench of Modeler. And we're going to use as target the prediction of the neural network. So now we're going to model by stream processing the logistic regression. We start with the defining a target that is a binary 0-1 logistic regression as response variables of our model. We define the terms building the model, so the 5 feature predictors, and remember that B and E have been already identified by MANOVA and previously by predictor importance in the neural network as the most relevant one, and less relevant are the A, C, and D, and F. Let's see if we can replicate the MANOVA results, basically. No analysis weight or offset fields to be applied. Certainly, we have to regularize this logistic regression. As I said, there are options. We're going to go with the L2REG method to reduce overfitting on the model. And yeah, we're going to calculate the prediction importance as well. So I think we are ready to go with this model. Let's just run this logistic regression regularized with REG method. Let's just stream through the data source into the model. We just generated this logistic regression. Let's just wait a second. Now here we got the model, and let's just check out the model. So as a start, let's see, we have the target field is the predictive, the prediction of the original, of the previous neural network. We're gonna use as a link function the logit. Then we're gonna go through. Yeah, the logistic model has identified the very same, as we see, B and E as the most important predictors, even in this model. The same structure basically is appearing, and we can just go to check out the parameter estimates, and that's quite important, because actually the beta values of the exponentiated the log of the odds of the beta values of the log of the odds are just telling you exactly what we wanted to get. The misclassification error rate is very reliable for, as we said, the B feature with 0.007 significant level, or false positive error rate very low, as well as the other one very low, below the standard 0.05 is the E feature. And in fact, we are getting the same values. So the beta values of the logistic regression are significant for B and E. Clearly, we want the odd ratios that will tell us how many times there is the likelihood that the E or B are just affecting the target variable that is the prediction, the original prediction of the neural network. Substantially, we got the same results. Let's just calculate one of those. So let's get, for instance, the significant beta values of the logistic regression for the E predictor feature that is significant, the E. So let me enter and try to find out the exponential value, the exponentiated beta value. So is let's just so basically what he's saying here, there's 11.93 is the exponentiated exponentiated beta values of the logistic regression. He's telling that any increase in the 1 unit into the E feature will increase the chance of being into the target category 1 of a multiplicative factor of 11.93. This is actually a strong interpretation and capacity by the Page algorithm to review the role of the E or all the other significant like B feature predictors by using the exponentiated beta values of this regularized logistic regression, and showing that by the neural network we identify that these two features are important, E and B, and E has the value of 11.93 multiplicative factor higher to be into the category 1 of the prediction target feature. The very basic fact that we need a regularized logistic regression can be explained by showing that we can run the very same model but using a normal logistic regression, and we see that there would be overfitting with error rates under out of control. In fact, if we run a target as we did before on the regularized logistic regression and the 6 feature predictors modeling with the manual enter, we can just run this model. Let's see what happens. 50% complete. This is the very same kind of model, but is not regularized. So let's just read the results. So still the predictor importance B and E remains. That's very interesting again, but if we look at the basically the log likelihood levels is not finding a solution, because basically the minus log likelihood is tending to 0. So this is really an overfitting conditions. Even this pseudo Nagelberg R square is 1, 2i, and in fact the standard errors in the beta values by this model, the standard logistic regression, has standard errors way beyond control and providing exponentiated beta values that are completely out of control. I think this is again a way to show that the regularized logistic regression has to be used. With this, I just show that the Page algorithms, by application of even the second solution, the regularized logistic regression, can identify the correct parameters, the correct feature predictors like the MANOVA models, and providing interpretation in terms of odd ratios for the significant features according to the neural network model.